All right, here we go. A little test review video for you. Hope it helps. Hope you wear it out too. Make sure you know all this when you come in tomorrow. Number 1 says write the quadratic formula, identify the discriminator, and explain what that tells you about your zeros. We have a song for a quadratic. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. That's the quadratic formula. The discriminant is just the b squared minus 4ac part. And what it tells you is the number and type of solutions you're going to get. Like 2 reals, 1 real, 2 imaginary output of sol of solutions. All right, so that's all you got to do for number 1, and make sure you know that. Number 2, solve that equation on number 2 right here. So it's got a square in it, which means I'm going to have to take a square root. But before you get there, let's divide both sides by 3. Do not distribute into something that is squared, ever, never. All right, so when I divide, that gives me x plus 1 squared equals negative 18. Now take the square root. Square root both sides. On the right-hand side, it just cancels out the square. Left-hand side, don't forget your plus or minus. Sorry, right-hand side, don't forget your plus or minus. Take out the I, and let's break down the 18. 18 is really 9 times 2. The square root of 9 is 3, so it comes out. Square root of 2, I do not know, so it just stays in there. And then to finish it up, I'm just going to move the 1 to the other side, make it negative 1, plus or minus 3i on 2. It needs to look just like that. That's what your answer should look like, number 2. All right, let's keep going. Number 3 has all the imaginary number operations. Just make sure you do the right operation at the right time. Part A has an addition symbol. Do not do FOIL. It says add, so just add the 2 real numbers. 2 and negative 5 is negative 3. Add your imaginary numbers. I and negative 7i is negative 6i. Guys, that's it. Don't make it harder than it is. Part B is also addition. So add straight across. 4 and negative 3 is 1. Negative 1 and negative 6 is negative 7i. Probably shouldn't have written it like that. Probably should put 1 minus 7i. That's my mistake, but that's still correct. I would expect 1 to maybe be subtraction tomorrow, so just subtract straight across if that's the case. Part C, distribute. 3i times 5 is 15i. 3i times I is negative 3i squared. Never ever leave an I squared. Don't forget I squared is really negative 1. And the negative 1 times negative 3 makes it positive 3 plus 15i. All right, D is probably the worst part. You got to multiply by the conjugate, and I know you knew that. The conjugate of 1 minus I is 1 plus I. When you multiply your denominator, you can just do, remember, just do foo, because they're conjugates. First is 1, last is minus I squared. And don't forget, I squared is really negative 1, so 1 minus negative 1 is really 2, so I'm going to have 2 in my denominator. In my numerator, you have to do FOIL, so do first, outer, inner, and last, which is 3i squared. Now again, first thing I say is I got a 2i and a 3i. That's 5i. And I got this 3i squared. I squared is negative 1, which makes that 3 become negative 3. So I have a 2 minus 3, which is negative 1. And there's your final answer right there. All right, the next one is flat out FOIL method. So to do FOIL, again, it's like I just did. First, outer, inner, and last. And you can combine your i's. Negative 8i plus 3i is negative 5i. The I squared is negative 1, which makes that negative 4 become positive 4. Going to add it to the 6, which is 10 minus 5i. And that's it. One more here. One more FOIL. First, 4, outer, 1i, inner, negative 8i. Last, negative 2i squared. I squared is really, well, got these i's in the middle again. Negative 7i. I squared is negative 1, which makes the 2 become positive 2. Add it to the 4, which is 6 minus 7i. And that's it. That's all the number 3. Number 4, solve by completing the square. Remember, that's where we did the gesture, half the middle square, add to both sides. But the first thing you need to do always is move the constant term over. So I'm going to move that over, x squared plus 6x. Leave some space to complete the square. Half of 6 is 3. Square it. It would be 9. Make sure you add that to both sides, not just one of them. The right-hand side becomes 13. Sorry about that. Left-hand side. Whatever the half was, will go inside your parentheses here. X plus 3 squared. Now, to get rid of the square, you square root both sides. So I get x plus 3 over here. Over here, I cannot break down 13, so it just stays inside. Don't forget your plus or minus sign. Move the negative 3 over. It goes in the front. And there it is. Negative 3 plus or minus is square root of 13. And all of your answers will look like that. Part B, move the 8. Same kind of problem. X squared plus 4x equals negative 8. Here we go again. Half the middle, which is 2. Square it, which is 4. Add it to both sides, not just one of the sides. And over here, the half goes in here. X plus 2 squared. Over here, negative 8 plus 4 is negative 4. Square root both sides. You get x plus 2 equals plus or minus. Now, got to take out an I because it's negative, and because that, but that would leave this. That would leave square root of 4, which is 2. To finish up, I'm just moving that 2 over. It's going to go in the front. It's going to make it negative 2 plus or minus 2i. All there is on that one. Number 5, find the absolute value. It's been a while since we've done this one, but the formula for doing absolute value of a complex number was you do the square root of a squared plus b squared, where that is your a and that is your b. Just the 7, not the I. So to find the absolute value, I'm going to do the square root of negative 3 squared plus 7 squared. That's going to tell me how far that point is from the origin on the complex plane. So I would get square root of 9 plus 49, which is a square root of 58. I know you want to break down 58, but believe it or not, it doesn't break down. So we're stuck there. All right, number 6, write the given function in vertex form. Again, that's completing the square. So put the x squared and 8x together, leave the 19 just sitting out here, and leave room to complete the square. Now this is a tad bit different completing the square. You still do half the middle, which is negative 4. Square it, which is 16. But the difference is, instead of adding to both sides, you add it to the side and you subtract it to this side, which will give me this. It takes 2 lines to get there. X minus 4 squared, and that's going to be plus 3. It also said do this, find the vertex. That's vertex form. Your vertex is the opposite of what's inside, exactly what's outside. 4, 3, there you go. There's your vertex. Number 7, solve by the quadratic formula. You can't use quadratic formula unless everything's on the same side. So I'm going to bring the 18 back over here, and the reason this is a good one to solve by quadratic formula is because you have an odd number in the middle. Completing the square would be a little messy. So just go work through it. X equals negative b, which is negative 3, plus or minus the square root, b squared minus 4ac all over 2a, which is 2 times 1. So let's work through there. Work out what's inside your radical. We did these, we actually did that part first. That's going to be 9 minus 72. 9 minus 72 would be negative 63 over 2. And sometimes you're going to be done right there, but obviously we're not this time because there's a negative inside, and we can break that down. So what I'm going to do first is I'm going to take out the I, plus or minus I on 63 over 2. And I know this. I know 63 is 9 times 7. So I'm going to have 3 plus or minus. That square root of 9 is 3, so I'm going to pull it out with the I. The 7, I don't know the square root, so it stays in, and the 2 on the bottom. Okay, all there is to that. Number 8 is this asking for a discriminant. Don't forget discriminant is just this part, b squared minus 4ac. But you can't do that either unless you have everything on one side. So I'm going to move the 2x over here first, which would give me 2x squared plus 4x. I'm also going to move this 7 over, which would make it 3 minus 7, which is negative 4. Now you can do your b squared minus 4ac. b squared is 4 minus 4ac is negative 4. I have 2 negatives, which is going to turn it to a positive. 8 times 4 is 32. 16 and 32 is 48. Because it's positive, I'm going to get 2 real solutions. And that's all you got to do. Find the discriminant, tell what it tells you. The second one, same kind of problem. Move the 4 over, x squared minus 5x. That's going to make it, if I move the 4, it becomes minus 4. 10 minus 4 is 6. And do the same process. B squared minus 4ac. 25 minus 24 is 1. Again, that's positive, so you get 2 real solutions. Now, if you get 0 for an answer, it'd be 1 real solution. If you get a negative for a discriminant, you get 2 imaginary. All right, graph these. First of all, this first one is already in vertex form. It's ready to go. So let me blow this up a little bit. So I'm going to go to 1, 3, 1, 3. Right, there's my vertex. It opens up because the 2 right there. So I'm going to, and it's solid because there's an equals. Now, I got to figure out where to shade on this, whether inside or outside. So what I always do, I told you the best point to pick if it's in vertex form is go directly below. And I'm going to plug in that point right there, which is 1 0. Now you can also plug in 0, 0 if you want to, but I'm telling you, this point's going to be even better. If I plug a 1 in there, come on now. If I plug a 1 in there and a 0 over there, first off, if I plug a 1 in here, that parentheses becomes 0. 0 times 2 is 0. That just leaves a 3 and a 0 over here. So is 0 greater than 3? No, it's not. So that point did not work, and it's outside, so that means I'm going to shade inside. All right, that's all there is to it. Look at the second one. Same deal here. This one, though, is not in vertex form, so what I'm going to do is I'm going to do this. I'm going to do the negative b over 2a to find my vertex. I got to have my vertex. So negative b over 2a would be negative 4 over 2 times 2. If you work that out, you get negative 1. So my vertex is going to be negative 1 something. I got to find the y. And the way I'm going to find the y coordinates, I'm going to plug the negative 1 back in. So I get 2 times negative 1 squared plus 4 times negative 1 plus 5. So that's 2 minus 4 plus 5, which is 3. So my vertex is negative 1, 3. So I'm going to go there, negative 1, 3. Now because it's a positive 2 in the front, it also opens up. It's going to open up just like this, which means what I know is this is one case, but because it's not in vertex form, I am going to use 0, 0. So I'm going to plug in this point, 0, 0, and just see if it works. Now the great thing about this standard form is if I put 0 in for y, that's 0. If I put in for x, I get 0 over there, 0 there, and 5. So really all I'm looking at is the 5. Is 0 less than 5? Yes, it is. Also, I made one mistake. I see that parabola should have been broken. Sorry about that. I just made it broken for you. And now I'm going to shade outside because the point did work. 0, 0 did work, so we'll shade outside the parabola. All right, so 2 types of parabolas there. Make sure you can graph each type. Number 7, solve, then write the inequality solution in inequality notation. Now these are, I'm going to factor these, both of them. So I'm going slide divide slide. So what I'm going to do first here is I'm sliding the 2 over here. If I slide the 2, that becomes 6. Factor what you have, which would be x minus 6, x plus 1. If you factor that. Now divide by the 2. 6 divided by 2 is 3. You can't do 1 divided by 2, so I'm going to slide the 2, make it 2x plus 1 right there. And what that tells me now is now I can draw my little line right here, my little number line, put the 2 points on here, the zeros. That 0 is 3. This one's negative 1/2. I'll do that from right there also. Put negative 1/2 here, put 3 there. Now what I'm going to do is I'm going to plug in a point and see where it's positive or negative. All I care about is where is it positive or negative. So I'm going to plug in 0, 0's in there somewhere. Way back here at the top. I'm going to plug 0 right there. That'd be 0. That'd be 0. That's negative 3. So is negative 3 less? Is negative 3 negative? Yeah. So that means everything between those two is negative, which means everything out here is positive and everything out here is positive. So now look back at your sign. Our answer needs to be less than 0, which is negative. So where is it negative? It's negative between negative 1/2 and 3. And that's your answer. All right, so factor it, find your zeros, plug in a number, see where it works, and go from there. Let's do one more of those. Probably need one more of those. I'm going to do the same thing, factor this one. So I'm going to slide the 4, make it x squared plus 8x minus 84 greater than or equal to 0. So I'm looking for positive. Factor that. I have x and x. So I need factors of 84 that are going to give me 8. Which I'm pretty sure is 14 and 6. So I'm going to go plus 14 minus 6. But don't forget the 4 here. We got divide by the 4. So I'm dividing that by 4 and that by 4. Now one thing about dividing that is they don't divide, but they do simplify. That's going to be 7 over 2. This is going to be 3 over 2. Slide the 2. 2x plus 7. 2x minus 3. All right. Now you need your 2 zeros. If I were you, I'd get the zeros from the line right here. That kind of tells you. One of my zeros is negative 7/2. Look right here. The other one is 3/2. That's what's going to go on my number line. So I'm putting a negative 7/2, a positive 3/2. And I'm going to do the same thing. Zero's in here, so I'm going to plug in 0 way back here at the top. And if I do that, I get 0 and 0 and negative 21. Now, that's negative, which means everything in here is negative, which means everything here is positive, everything out there is positive. Now, I need the positive part. The positive part is less than or equal to negative 7/2 greater than or equal to positive 3 halves. And the reason I did equal to on that one is because that's what it gave me in the problem. On the last problem, let me move this over a little bit. On the last problem, it just had a regular less than, so I did not use an equals sign in my answer. All right, if there's one in the problem, use it in the problem. A couple more here. Write a quadratic function that has these characteristics. Remember what we talked about in this day. Whatever they give you, use what they give you. Use what they give you. So here's what I know. Y equals a. X minus 2, that represents this one. X minus 4, that represents that one. And it goes through this point. Why does it go through that point? Well, because it works. So I'm going to plug it in. Plug the negative 6 in for the y. Plug the 3 in for the x, just so we can figure out what a is going to be. So I get negative 6 over here. That's 1. That's negative 1. So I really have negative 1a equals negative 6, which means a is 6. Write your answer. Y equals 6. X minus 2 times x minus 4. And those points should work. You should be able to plug in 3 right there and get 6, which it does. Looks good. Let's go to the next one. Actually, it may be on the same slide. Let me see here. Nope. Okay, there's part B. This time they gave you the vertex. Remember, use what they give you. If they give you the vertex, use vertex form. So I'm going to say y equals a x plus 3 squared plus 4. Now, you need to find a, so here's the deal. It goes through 0, 1. Why? Because it works. Put the 1 in for the y, put the 0 in for the x, and let's solve it for a. Right here, that's going to be 3 squared, which is 9a. I'm going to go ahead and move the 4 over. Well, I didn't do that, so I just leave the 4 here. Now move the 4 over. If I do move the 4 over, that side becomes negative 3. This is 9a. If you divide, you get negative 3 ninths, which is really negative 1/3. There's my a. So my equation is going to look like this. Y equals negative 1/3. X plus 3 squared plus 4. All right, so whatever they give you, use that one. Okay, part C was the day we spent quite a while doing these. I only did a couple of them, and they all came out to be fractions. Hopefully this is one that comes out good. We're about to find out. Okay, so here's what our equation looks like. This is standard form, ax squared plus bx plus c. Plug them in. Just plug the points in. I'm going to put negative 1 in for y. I'm putting my negative 2 in for my x's. All the x's plus c. Okay, the great news here is I have a 0 out of the y-intercept, so I'm going to put the 3 in for the y, put a 0 in for the x's. And remember we talked about that day? You really don't have to do that step because we already know our c is going to be 3. Our c is going to be 3. Plug this point in. 1 for the y, 4 for the x's. Just like that. Now, here's what I was talking about. This c, because those are 0, c is 3. So what I have, when I move this up just a little bit, I have from my first equation right here, I'm going to change colors on you, I'm going to have 4a minus 2b equals negative 1 plus c, sorry, really plus c. This equation is going to be 16a plus 4b, my b's are getting bad, let me do that again, plus 4b plus c equals 1. And I know c is 3. Now here's what I'm going to do. Because I know c is 3, I'm going to go ahead and take the 3 over there. It becomes negative 3, which means that's going to become negative 4 on that side. So I'm going to go ahead and erase that c right there. Don't need it anymore. Same thing in the second one. I know c is 3. If I take the 3 over there, it becomes minus 3. 1 minus 3 is negative 2. So I'm going to erase all that and just make that negative 2. All right, so now a couple options here how to do this. You can reduce this equation if you want to, make your number smaller, however you want to go. Matter of fact, let's do that. Let's leave this equation the same. 4a minus 2b equals negative 4. And on the second one down here, I'm going to divide everything by 2, make that 8a plus 2b, there's what we wanted, is negative 1. Now I can just add the equations together. When I do that, those are gone. So I get 12a, darn it, is negative 5. I said darn it because I got fractions again. Negative 5/12. There's my a, yippee. To find my b, I'm going to plug it back in. I'm going to plug it in. I guess I'm plugging in right here. So I have 4 times negative 5/12 minus 2b is negative 4. Now, 4 cancels with the 12 3 times, so I have negative 5 thirds. Minus 2b is negative 4. This is fun. Taking the 5 thirds across. 4 is really 12 thirds, so it's going to be negative 12 thirds plus 5 thirds, which is negative 7 thirds. And I'm going to divide that by negative 2, so I get 4 thirds. That's my B. So there's my A, there's my B. My C is 3. So my answer, finally, is y equals negative 5 twelfths x squared plus 4 thirds x plus 3. And that's it. All right, that's a doozy. It is what it is. Hopefully tomorrow on your test you won't have fractions, but I have to check. All right, last one. It says a volleyball is hit upward by a player in a game. The height, h, in feet of the volleyball after t seconds is given by that function and is quadratic. What is the maximum height of the volleyball? Explain your reasoning. And after how many seconds does the volleyball reach its maximum height? Okay, part A, the maximum height of the volleyball actually occurs at the vertex. I mean, think about it. It's going to be a parabola shape, so the height is going to be at the vertex. That's the highest point of a parabola. So I'm going to find the vertex. So I'm going to do negative b over 2a. So I'm going negative 30 over 2 times negative 16, which will give me 30 over 42 because they're both negative. It's been both positive. 30 divided by 42 is like 5/7. So I'm going to plug that in back to the equation to find my y. So my vertex is going to be 5/7 and something. Probably should change that to a decimal. We'll do that in a minute. Plug it in. Negative 16 times 5/7 squared plus 30 times 5/7 plus 6. I'm going to pause this a second, get my calculator and punch it in. I'll be right back. Okay, I know you didn't know I was gone, but I was actually punching in my calculator. I got this. I got 19.27 for my y. I also went ahead and plugged in 5/7 to see what it was as a decimal, and it was basically 0.714. So I'm going to go 0.71. So my vertex is 0.71, 19.27. That's my vertex. Now, part A asks me this. It says, what's the maximum height? Now, look where the height is. Look where the h is in our equation. It's our usual y, so the height is the y. So my A, the height of the volleyball is 19.27 feet. That's the answer to part A. Part B says, how many seconds does a volleyball take to reach the height? Now, t is time. That's the x. All right. So the x part of my vertex, the answer to B is going to be the x part of the vertex, which is the time it took to get there, which is, barely over half a second, so 0.71 seconds, which just makes sense. And then it says, part C, after how many seconds does it volleyball hit the ground? Well, the vertex, think about it. A volleyball is this, and there's the height of the volleyball. The time is, that's halfway to the ground. That's half the pathway that it travels. So I'm just going to double the time right there. If I double 0.71 seconds, it's 1.42 seconds. That's how long it would take to hit the ground. Hope that made sense to you. One more time. They gave me a quadratic equation, which is the path of the volleyball, a parabola, an upside down parabola. That's why t squared is negative. The maximum height is the vertex, so I found the vertex. I'm going to use my calculator to help me. The maximum height is the y. Look where the h is. It's on where the y would be. How many seconds? Seconds is x's. That's the time. That was the x coordinate vertex. And then how long does it take to hit the ground? Well, it took half the time to get to the top. It's going to take half the time to get back down. So double your time to get to the top to get when the volleyball hit the ground again. Hope that makes some sense. I'll be at school early in the morning if you need me. A and B, I'm free, so let's do good tomorrow. Actually, I'll be too late. So anyway, hope it helps. See you tomorrow.